This is an introductory video on using safe sightings of signs and signals, or SSOSS. In this video, we're going to walk through how to use the program and all the input files that you need. There is another video in the link description below where you can see what this tool is and how agencies can use it to ensure that their traffic signals are visible and unobstructed. It's a free tool and everything you need is outlined in this video, and all the code is open source. Step 1 is collecting data. This consists of two things. 1, recording a video file, and 2, recording a GPS location file or a .gpx file. Both of these can be done with free apps using a mounted cell phone. And really the first step is to drive all the approaches of a traffic signal so that it can be captured in the video and later extracted for a sight distance image. For driving in a grid, you may consider a north-south and then an east-west type of movement for all the corridors. And for driving in a non-grid, you may consider making right turns at each intersection and capturing the approach of the perpendicular street along the way and continuing as shown here. And generally avoiding left turns and trying to avoid reverse can also help. But always drive safely and obey the rules of the road. For your video file, you'll want to ensure that your video is being captured at 30 frames per second or more. 60 frames per second is ideal. You'll also want to make sure this video is a high resolution, about 2 megapixels or more. Using a modern cell phone is good practice. You'll want to mount this in a car in a location that doesn't shake and provides for continuous recording at approximately 3.5 feet high. You also want lots of storage space so you can perform a longer drive, and make sure that the temperature of the vehicle does not get too hot so the cell phone can continue to operate. For the GPX file, you want to use version 1.0, and it's best if you can record the data every second. So once you have a video and a GPX file, then we can start to use the program. Download SSOSS.exe. So moving over to the GitHub page for safe sightings of signs and signals, we can learn a little bit more about the program and how to process the video and the GPX data for our sight distance images. So over on the releases on the right, we can find the latest exe file for Windows, which is really the easiest way to use the program. Gives a little graphical version of it. So this latest version here is, we can click and download that. It is 81 megabytes, but once we click continue download, we can download that just fine. So it is open source software, but it's reliable and all the code is visible if that needs to be checked out. So go ahead and pasting that in our little project folder here. We're not going to open it with Windows, and we will click run. So once that opens up, we can see the graphical interface here and the different files that we need. So you have a static object CSV file, the GPX file, and the video file. And then the synchronization frame and the synchronization time. And so we'll walk through all these below. To start, we can even show a GPX file. So if we go ahead and load up our recorded GPX file, we can see what that will look like. Here's the GPX and video file that we have from the drive. And so we'll click run on the program. And again, this is just a free app that recorded the GPS location. And we can actually open this file and take a look at what's in here. So it's version 1.0, which is ideal. And then it includes the latitude and longitude and the timestamp. It also has the speed, the bearing, the additional GPS information, but really it's about that latitude, longitude, and the timestamp. And then we're logging every second, which is also another crucial fact so that you can have a high accuracy between points. And we're actually logging the millisecond, which can also just reduce error. So that's another helpful feature if your app allows it. So there's every second, and it's a big file because it's logged every second. So our program ran successfully, and you can see it ran 2,000 points to the GPX file. It shows you exactly what file ran, version 1.0, start time, and then the duration of the drive, 46 minutes, and then it will fill in the feet once it processes a little more with a static object file, but for now it doesn't. And then it does the total. We can also do this for the video file. You can just run the straight video file and it will process the video file and give you a basic summary of that information. So here's our video file. You can see it's completed successfully. So that's the video file, how big it is, 2 gigs, the resolution of it with the 2.1 megapixels. And then we're recording here at basically 60 frames a second, which is great. 30 to 60 is plenty. Total number of frames, and then total duration of the video, about 23 minutes. So that's the basic stats of those 2 files, but really, we really need to get that static object CSV file set up. And so we'll walk through that now. Static object CSV file for intersections. So to start, we'll just take a look at this video here. It's just a video of driving down Lombard, and here we are at Golf. It's a little choppy, but that's just because the computer was processing the recording of this, but it flows much nicer, and that's Octavia. So you can see where we are in the video. And notice the speed, we're getting green lights, there wasn't too much traffic, so we just had that good flow, which looks like the good points to synchronize or to set up later. So we'll go ahead and set up our Lombard intersection CSV file. And I will change the actual type of the file, but that's fine. So now you can open Excel, but I prefer to open it in text editor or notepad kind of thing. It's just blank. So we're going to start with the intersection ID, and then the street name of the first street, and then the second street. So looking at Lombard and at Goff Street. And if we go ahead and, while we're here, we're going to actually grab that center location of the intersection. So right clicking and clicking that top point in Google Maps here. So that's the center of the intersection point. You can also go down here and select that, but by doing the other way, it just automatically copies to the clipboard. So there's Golf Street, and then we'll paste in the coordinates of that center point. And so then we're going to need to capture some speeds, and so typically we start with northbound, eastbound, southbound, and westbound, working clockwise through the intersection, but just looking at this westbound approach that we drove on, we'll search the street view here for some speed limit signs. Going up a little bit, zooming in, nothing yet. This is probably one of the more tedious aspects, making sure that all the speed limit approaches are in the intersection file, but once it's done, it's done. So it looks like we see a 25 mile per hour sign there. So really what I just did by entering those 4 speeds, I said for the northbound approach is 25, that approach going eastbound, southbound, and then westbound. It's all 25 miles per hour. So that's something you'd want to verify for each intersection, but if we just drop in here, it's likely, notice there's a sign there, and 25. The next 4 items we need is a bearing. So if we see that compass, we're looking for that bearing, and you can see it's kind of just off of north, and it's actually in the web address. So if you look at the H, you can see that it's the number in front of that H. So 344 degrees is the compass bearing. And then we can do the same pretty quickly for this. So then we'll do the eastbound, and that is at 76. And you don't have to do the decimal, but we're just copying the whole thing. And then we're doing the westbound, even though the southbound will be next in the CSV file. 244. So southbound, I'm on the northbound approach, but I can just flip it around since it's a straight street. That's at 175, so that needs to go before there. So slip it in there, and then we delete that last comma. And that's what we have for one intersection. So we'll go ahead and copy that, and duplicate it a couple times, and then modify it for each of the 5 intersections that we're gonna change here. Now, what's nice about this grid layout is actually all the bearings will stay the same. And we're going to assume the speed limits are also the same for the whole corridor. The only thing that really changes is the number, street names, and the center point locations, which are all pretty quick to get. All these speed limits should be double checked. And changing these would just give us a distance intersection site distance that's further back. So for this last one, we'll actually change it to 35 just to show you that that image is a little farther back than the others. So yeah, since this is a grid, these are all the same compass bearings, so that makes it a lot easier. So we'll go ahead and load in the rest of these just by copying the center point. So there's the center point for Octavia, and we'll go ahead and fill in the rest. So now that we have our CSV file all ready to go, we'll save it and exit. Opening up our program, we can now load that CSV file in and just make sure that all the intersections are loaded okay. All right, looks like it ran successfully. So here we have a process 5 lines of the CSV file for a total of 5 intersections. That's exactly what we expect. And that video file was still in there, and so it processed the summary again. Video synchronization process. All right, so to get our video synced up, we're really missing the sync frame and the timestamp. And so to get that, we're going to use this bottom tool at the very bottom of a start frame extract for the starting with a certain seconds, and then an end frame extract. So we're going to look at the clip, and we're just driving smoothly here. So right here, we're going to pause it, and we have a bunch of thermoplastic on the ground. We have some manholes, and we're at the center intersection, so we have a good idea for where we are, and we can probably correlate this to a good GPS point. And so we want to make sure we can find a location for this, or a timestamp for this video. So now we're going to open up the GPX file, and here we're going to scroll down a bit, and we're going to look at that course. If we look at the course, we can see like we should be going that westbound direction on Lombard. And we should also have a speed. So here we're at 0 speed. We wouldn't want one of those points. So we should look around 260, 270 degrees. We have a long GPX drive, but we're just in this one little segment here. Now this one, we have a speed that looks a little low, but we can go ahead and copy the latitude, longitude, and just paste it in. And from there, we can pull up that point. Now it's a little advanced of Goff. We're down at Fillmore, so we're a couple intersections too far. So let's go back up, and now, again, the bearing shouldn't change. It should be at 260, and we should have a good speed. So this is in meters per second, so 10, 12 is a good. So let's go grab this point, paste that into Google Maps. Again, changing that long area into a comma. All right, let's see where that puts us. That puts us right in front of Golf. However, that's not exactly where we wanted in the video. We want that thermoplastic so that we can really understand. So if we just look at the next second in the GPX file, we might be right in that zone where that crosswalk is. Now, we were in the different lane, but that's just a GPX error. I do think it's partly because of the high buildings that we were driving through. It doesn't give the best GPS signal, and it might increase the error, especially in that certain direction. Sometimes the signal can bounce off buildings, cause some little bit of error. Okay, so this looks great. So we're right in that crosswalks. We have that marking in the video, and so we should be able to understand that point with our video. And notice we're not in the middle of the crosswalk, we're actually in like the first 25% of the crosswalk. So going back to the video, looks like right now we're at 4 seconds. So let's start at 3 seconds, and then we'll go up to maybe 5 seconds. So here everything is blank except for the video. We got to put the video in. And then at the very bottom, we're going to start frame at 3 seconds, and then we're going to do it to 5 seconds. And so now it's just going to pull out all the pictures that make up the video at that point. So again, that's 3 seconds of video, all 3 seconds, all 4 seconds, or just the 2 seconds, I guess. And then it's 60 frames. So it's about 120 pictures that we should be able to export. And this is going to come in right where the video is as an out folder. And from there, that's the video clip name, same name of the video file. So that pulls up. And then it's just going to write a bunch of pictures into there under the frames folder. So here we go. We're already writing, and then it shows what they did. And it literally just names them as frame numbers. So there we are, driving. And we're going to want to skip forward a little bit. Yeah, each of these is, 1/60th of a second. And so we don't move very far in each picture, which is helpful because then we can get the exact spot. This gives us great resolution. So here we are. The GPX point was right over there, but we're going to assume that it's actually shifted to this point in front of us because the phone was in this car. So here it looks like we're right over this. The full crosswalk is about 10 feet in that stripe. But from the phone or this video to that point right there in front of the crosswalk, that's like 20 feet. So really, if we're going to try to get that GPX point in the crosswalk, we want 20 feet in front of that. Let's take a look at where the hood of our car should look like if we go 20 feet in front of the GPX. Now, no, the distances in these pictures are just very skewing. I mean, it just looks, as you get further and further out, it just looks like less and less distance, but it's significantly more. There's that sewer cap we can see. So let's go ahead and shift that over. If we measure out 20 feet, we can see we're still a gap between that sewer cap. So knowing that, if we look at the pictures, we can find a bit of a gap still between that manhole. And then, so we're still, so right around here somewhere, the phone and the GPX are right over the thermoplastic. So this is a bit of an approximate, and that's why it's important to use this image to measure your vehicle. And so really every time you mount your phone to record these videos, you're gonna want to measure this. And so just taking a wheel to see when that first point on the ground in front of the car is visible. Once we get the frame lined up, then we're going to note which frame that is in. So it's 279. We definitely want to remember that, and so we'll create a specific file. We're going to make a new text file called sync.txt, and it's just a way to just remember exactly, what we're doing. So this is the video file, lombardclip.mov, and then we'll do a comma, and then that was frame 279. And the last point is going to be the timestamp that the GPS gave us. So we grab this exact timestamp right here. So with that timestamp now, we have everything we need to synchronize this video. This is a clean way to save these approaches in case you have lots of video files that, you sync over time and you forget what the sync is and you have to resync it. So this is a clean way to kind of save that. So with our sync frame, we put in 279, and our timestamp, we just paste it in. This provides the video an actual time reference, so it can extract the appropriate frames. So loading in our GPX and CSV as before, we are going to include this label feature that labels at the bottom, and there's an option here to create a GIF. If like the image is blocked a little bit, you can generate a GIF. We'll leave it unchecked. Well, yeah, so if the image is blocked a little bit, you can generate a GIF. So then it can, give you a little bit more insight. However, it generates a bunch more images and takes some more time. So hitting start will let the program run. Yeah, now this is a short video clip, and this is only for 5 intersections we're trying to extract. And so this is going to be a bit quicker than normal, but if you have an hour or 2 hour video or longer, it can take a while to process all this. So here we're getting some video summary we've seen before, but now we're getting that video synchronization information. You can see the signals have been captured, and now we get the total distance for the GPX, and we see it's logged every 1 second or so. So that's really helpful. Now we have that synchronization in there. It knows when the start of the video is and when it ends. And so that's really what it gets. So it found these signals at number 1, and at point 3, they're all, point 3 means it's westbound, where point 0 would be northbound, point 1 would be eastbound, point 2 would be southbound, point 3 is westbound. So it's kind of a clockwise starting at north for each approach. And then it shows you which distance based on the speed. That last one we did change. Okay, so now it runs. Looks at completed successfully, which hopefully you'll see too. And now it's just saving those actual pictures. There's 1, 2, 3, 4, and it did a search and found the last one as well. So it's just this is processing stuff. It looks better on the command line version, but here you can see it in the GUI. And then 5 of 5. So those are the pictures, they're all done. Let's go take a look and see what they look like. So again, in the out folder, and for that video, instead of frames, we're actually going to look at signal sightings. So from here, we have our pictures. And because we clicked the labeled, we have a nice labeled folder. So they're the same images, they just have a label at the bottom. If we take a look, we can see we have each picture labeled with the street name, the distance, and a timestamp under UTC. That's just a unique identifier essentially to help understand when the picture was taken. In case you go back over that intersection at the same approach, you have a different timestamp on that. So here's just the straight images. You can notice we're about 215 feet. Again, signal looks about the same distance. Given that approximate location, again, same. And then this last one, this one looks a little farther, and that's probably the 325 feet. So just because we changed that speed limit, but it's still 25. I just wanted to show. If we check out the labeled folder, we can just see a similar thing, just a label on the bottom. So you can kind of easily know which direction you're facing and which signal approaching without looking at all the information in the title or in the file name. You can see in this picture that all the signals are clearly visible, and we don't have any obstructions, and so we can move on to reviewing the other site distance images. So now we'll run the GIF and we'll take a look at those. So here's an example of one image. Notice the pole on the left and the car on the right. And now here's the GIF of that. And then the pole on the left and the pole on the right there, but we're seeing before and after that point. And here's the image again. So we drove through before and after that to really see if the signals were obstructed. So taking a look at a second example, we can see the 30 mile per hour on the left and the white car on the right. And now playing that same GIF, but at half the speed, we can see the sight distance right here, but we're seeing before and after. So if one image doesn't come in focus or it's obstructed, you might be able to use the GIF tool here to help verify that that image is okay. Now using SSOSS, there are sources of error, and I try to be transparent with these in the sources of error section of the README page on the GitHub. So you can see the different sources of error, GPS, using that center location instead of the stop bar. Vehicle motion, depending on stop and go, could have a bit off. And then make sure you calculate your vehicle with the view of the roadway. Make sure you understand how far away that first point on the ground is. And then obviously syncing the time. That's probably one of the easiest ways to grow your error. So you'll want to make sure that you're syncing your video to a really accurate location that you feel is confident. So as I learn and understand how we can minimize these errors, I'll update that section. With that concludes our process for using SSOSS. Thanks for joining us, and I hope that was helpful. If you do have additional comments, feel free to leave those in the comment box below.